Welcome to AI for Specialists. Today we're embarking on a deep dive into something, well, pretty monumental happening in the global semiconductor industry. It feels a bit like a sci-fi plot twist, actually. For decades, AI was, a demanding customer of chips. It needed all that power.
Right, it was all about feeding the beast, so to speak.
Exactly.
Yeah.
But now, the script is completely flipped. AI is arguably becoming the most powerful tool for creating the chips themselves.
Mm-hmm.
And that's sparking this new kind of high-stakes arms race for design supremacy. It's a total inversion.
It really is. And our mission today, I think, is to unpack how these AI-driven design methods aren't just like tweaking things at the edges. They're fundamentally reshaping competitive advantage. We need to look at the key players, the big shifts, basically what's going on under the hood in this massive industry.
That's a huge claim and inversion. So, okay, to really get this, let's talk about the old limits. We hear about Moore's law hitting walls.
Yeah, that's the common narrative.
But what does that actually mean for chip design, on the ground? Because it sounds like the classic electronic design automation, the EDA workflows, they're really struggling.
Oh, they are. They're buckling under the sheer complexity of modern chips.
I read that designing a cutting-edge 3-nanometer chip can cost upwards of, $1.5 billion?
Easily. Sometimes more.
That's not just expensive. Getting that design wrong is, it sounds financially catastrophic. Is that the main pain point for engineers?
In some sense, yeah. I mean, imagine trying to manually place billions, literally billions of microscopic components perfectly. Human ingenuity, even with traditional EDA tools, just can't keep pace anymore. That's the bottleneck. And this is precisely where AI steps in. These new AI-powered tools, they're automating incredibly complex tasks, like optimizing chip layouts for PPA.
PPA, that's power, performance, and area, right?
Exactly. The holy trinity of chip design. Every milliwatt saved, every tiny bit of performance gained, every square millimeter shrunk, it all counts. It directly impacts cost, speed, how much energy the chip uses. And AI is achieving, almost superhuman results here.
Superhuman, how so?
It's compressing design timelines.
Yeah.
Tasks that took months can now potentially be done in weeks, or sometimes, believe it or not, even hours.
Wow.
Hours. This isn't just a small improvement, it's a disruptive leap. It completely changes the economics of designing chips.
That acceleration is incredible. Okay, so who's leading this charge? You mentioned key players. I understand two giants were really at the forefront, NVIDIA and Google. But they have pretty different strategies, don't they?
Radically different, actually. It's fascinating to watch. NVIDIA is going for what you might call a horizontal platform play.
Horizontal, meaning?
Meaning they want to provide the tools and platform for everyone else. They're leveraging their, frankly, near monopoly position in AI chips.
Wasn't it over 80% of the market last year?
Something like that. And their proprietary CUDA software platform is key. Take their Calitho platform, for example.
Calitho, what does that tackle?
Lithography. That's the super precise process of basically printing the circuits onto the silicon wafer. It's a huge bottleneck in manufacturing. Calitho accelerates the computational side of that by, get this, 40 to 60 times.
40 to 60x.
Yeah. So a really complex, computationally intensive task that might take 2 weeks. They can potentially do it overnight.
That's game-changing for manufacturing speed.
Absolutely. And NVIDIA is working really closely with key partners like TSMC, the big manufacturer, and Synopsys, an EDA giant. They're positioning themselves as the indispensable arms dealer for the whole industry.
Okay, the arms dealer providing the tools. So while NVIDIA aims to be this universal enabler, Google's approach is different, more vertical.
Exactly. Google's strategy, their vertical gambit, was really born out of internal need. They have these massive AI workloads, right? For search, for cloud AI, for everything. They needed to optimize chips specifically for their tasks, so they developed Alpha Chip.
Alpha Chip. That sounds familiar, like AlphaGo or AlphaFold.
Same lineage, yes. It's an AI system specifically for chip floor planning. Floor planning is essentially figuring out the optimal placement of all the major blocks on a chip. It's a hugely complex spatial puzzle. What Google did, brilliantly, was reframe this puzzle as a reinforcement learning problem.
So the AI learns by trial and error, like playing a game.
Precisely. Just like AlphaGo learned Go, AlphaChip learns how to design optimal chip layouts. It explores possibilities humans might never even consider. And the results? It can generate complete high-quality layouts in hours. Compare that to human expert teams, which can take months.
Hours versus months. And are the results actually good?
Often better in terms of those PPA metrics we talked about, power, performance, area. And this isn't just theoretical, it's production proven. They use it for their own tensor processing units, their TPUs, like the Trillium chips powering their latest AI models like Gemini.
So they're using AI to design the chips that run their AI.
Exactly. And it's not just internal validation. MediaTek, another major chip designer, has also validated it externally.
Okay, so we have NVIDIA building the platform for everyone, and Google building hyper-optimized solutions for its own massive needs. This feels like more than just business models competing. It's like a battle for the future architecture of innovation itself, isn't it?
That's a great way to put it. Will the future be this open, platform-driven ecosystem NVIDIA envisions? Or will it be dominated by these vertically integrated sort of proprietary strongholds like Google is building?
And what about the traditional EDA players in all this? Companies like Synopsys, Cadence, Siemens, are they being left behind?
Not necessarily, but they are transforming. They have to. They're shifting from just selling software licenses. Think of it like selling shovels during a gold rush to providing what you might call automated gold mining machines. They're offering services that deliver optimized outcomes powered by AI.
Outcomes as a service.
Right. Look at Cadence's Cerebrus AI Studio. It uses something called agentic AI, multiple AI agents collaborating to orchestrate these really complex system-on-chip or SoC implementations. They're promising things like up to a 5x acceleration in time to market, which is huge.
5 times faster.
And importantly, tools like this also directly help address that other huge challenge, the talent shortage.
Ah, yes. So beyond the tech itself, what are the biggest hurdles the industry is facing in this new AI-driven era?
Well, you've hit on a critical point. It's not just about the algorithms. There's the massive resource barrier. Building cutting-edge fabs, the R&D, we're talking money, billions of dollars.
The barrier to entry is enormous.
Immense. But perhaps even more critical right now is the talent chasm. There's a severe shortage of skilled semiconductor professionals. Estimates suggest the industry needs about 1 million more skilled workers by 2030.
1 million. Wow. And are the required skills changing too?
Absolutely. The most valuable people now, and increasingly in the future, are those with hybrid skills. They need to understand hardware architecture and AI machine learning. That combination is gold dust.
Okay, so pulling this all together then, for our listeners, for you listening now, what does this all mean? What's the takeaway for the future of innovation and maybe your role in it?
I think the biggest takeaway, if we connect all these dots, is that the era of purely siloed expertise is, well, it's ending. Or it's certainly changing dramatically. The future of competition in this space won't just be about who has the fastest chip in raw Gersitz terms.
Right.
It's going to be defined by clever business models, by robust software moats like NVIDIA's CDA, and increasingly by geopolitical alignment, which is a whole other layer. Success in this new age, I believe, belongs not just to those who can build chips, but to those who can master the incredibly complex, interconnected, and intelligent systems that now design them.
Mastering the system that designs the system.
Exactly. So developing those hybrid skills we talked about, understanding both the hardware and the AI driving its creation, that seems paramount for anyone wanting to make a real impact going forward.
A fascinating and perhaps slightly intimidating future. Mastering the intelligent systems that design the chips. Well, that's all the time we have today. Until next time on AI for Specialists. Bye-bye.